Hello, this is eSpin Adam. We're happy to assist you with the upcoming presentation. Let us know if you need any help, and we'll be glad to be of service. Software Developer Training Program. Basic Level Programming. The Basic Level Programming introduces participants to the foundational concepts of programming, enabling them to understand and implement basic programming constructs and problem-solving techniques. Here are the 4 subtopics and key takeaways from this one-day's training program. 1. Introduction to Programming covers subtopics: What is programming? Overview of programming languages. Understanding compilers, interpreters, and IDEs, Software Development Lifecycle, SDLC. Programming is the process of giving instructions to a computer so it can perform tasks. Just like you give directions to a person, programming is how we tell a computer what to do step by step. Here are the key takeaways. What is programming? 1. Programming, process of creating instructions that tell a computer what to do. A computer does not think for itself. It only follows instructions that we, the programmers, write for it. 2. Program and programmer. A program is the list of instructions written for the computer. A programmer is the person who writes those instructions. 3. Key ideas in programming. To understand programming more clearly, here are the most basic ideas, step by step, which every instruction must be written in order, accuracy which computers cannot guess. You must be clear, repetition which computers are great at repeating tasks quickly, decision making which computers can choose between options if you write the rules. Overview of programming languages. A programming language is a special way for humans to give instructions to a computer. Each language has its own style and rules, but all of them share the same purpose, which to make the computer do useful work. 1. Low-level languages. These are closer to how computers actually think. They are powerful but hard for humans to read, used for operating systems, device drivers, or microchips. 2. High-level languages. These are easier for humans to read and write. They are more natural, like simple English. Most modern programming uses high-level languages. Example: Python programming. 3. General-purpose languages can be used for many things. Example: Python in apps, websites, data science, while Java in apps, games, large systems. 4. Domain-specific languages, made for special tasks. SQL, which works with databases. HTML, which designs web pages. Understanding compilers, interpreters, and IDEs. When learning programming, you will often hear terms like compiler, interpreter, and IDE. These are tools that help us write, translate, and run programs. Let's break them down step by step. 1. Compiler. A compiler is like a translator who converts the entire program into the computer's language, machine code, all at once. After translation, the program is saved as an executable file, a file you can run directly. Once compiled, the program can run very fast because the computer already has the full translation. Example: if you write a program in C language, you first compile it. After that, you get an executable file. Then, you can run it as many times as you want without compiling again. 2. Interpreter. An interpreter is also a translator, but it works differently. Instead of translating everything at once, it translates and runs the program line by line. It reads one instruction, translates it, and immediately executes it. This makes it slower than compiled programs, but easier to test and debug. Example: Python uses an interpreter. The interpreter reads that line, translates it, and immediately shows. 3. IDE. An IDE, which integrated development environment, is a special software where programmers can write, test, and run their code in one place. It usually includes a text editor to write code, a compiler or interpreter to translate code, a debugger to find and fix mistakes, extra features like auto-completion, error highlights, and project management. Example: if you use an IDE like Visual Studio Code or PyCharm, you can type your Python code, run it immediately, and fix mistakes, all inside the same program window. Software Development Lifecycle, SDLC. Process that software developers follow to create high-quality software. it describes the steps from the beginning, idea, to the end, software ready for use. 1. Requirement analysis, understanding the need. In this stage, the team talks with users or clients to understand what the software should do. Example, imagine a company wants an app to order food online. The requirements might be, customers can view the menu, customers can place an order, customers can make payment online. If requirements are not clear, the whole project may fail. 2. System design, planning the solution. Once the requirements are known, the next step is to design the software. This includes planning how the system will work. Example, for the food delivery app, the app will have two sides, customer app and restaurant app. Customer app shows menus, prices, and allows payment. Restaurant app shows new orders. This is like making a blueprint before building a house. 3. Implementation, coding the software. In this stage, developers write the actual code based on the design. This is where programming languages are used. Example, for the food delivery app, developers write code to display the menu, write code for the add to cart feature, write code for payment processing. This is like constructing the house according to the plan. For testing, checking for problems. In this stage, after the software is built, it must be tested to make sure it works correctly. Example, for the food delivery app, test if menu items display correctly, test if an order can be placed, test if payment works. This is like checking a house for leaks, electricity issues, or broken doors before moving in. 5. Deployment, delivering to users. In this stage, once the software is tested and ready, it is released to the users or customers. Example, for the food delivery app, the food delivery app is uploaded to the App Store and Google Play. Customers download it and start using it. This is like handing over the house keys to the owner. 6. Maintenance, improving and fixing. In this stage, after the software is released, developers must maintain it by fixing bugs, adding new features, or upgrading for new technology. Example, for the food delivery app, if customers complain that the app crashes, developers fix the problem. If restaurants request new features like special offers, developers add them. This is like doing repairs or adding a new room in a house after living in it. 2. Programming basics, covering subtopics, variables and data types. Operators, input and output operations, and hello, world. Program. Computers are powerful, but they cannot think for themselves. They only follow instructions. Here are the key takeaways. Variables and data types. 1. What is a variable? A variable is like a box with a label where you can keep some information. You can put something inside the box. Later, you can open it and check what's inside. 2. Why do we need variables? Without variables, you would have to keep track of every number or word in your head. Variables let the computer remember things for you. 3. What are data types? Every variable stores a certain kind of information. The kind is called a data type. Example, sorting items in a store. Apples go in the fruit section, milk goes in the dairy section, clothes go in the clothing section. Each type of data has its own rules. For common data types, A. Numbers, integer/whole numbers, used when you want to store a whole number. Example, age equals 25. B. Decimal numbers, floating point, used when the value has a point or fraction. Example, price equals 19.99. C. Text, string, used for words, letters, or sentences. Example, city equals Kuala Lumpur. D. True or false, Boolean, used when you only need yes or no, on or off, true or false. Example, is underscore raining equals true. Example, light underscore on equals false. E. List, collection of items, used when you want to store many values in one box. Example, fruits equals apple, orange, banana. Operators. 1. What are operators? Operators are tools that tell the computer what kind of action to perform between two or more pieces of information. Think of them like actions in daily life. You can add 2 apples, you can compare your age with your friends. 2. Types of operators. A. Arithmetic operators. These are for basic calculations, just like you do in math. Examples, if you have 20 candies and share them equally among 4 friends, each gets 5. B. Comparison operators. These check relationships between values. The answer is always yes, true, or no, false. Examples, you check if today's temperature is higher than yesterday's. That's comparison. C. Assignment operators. These are for storing values in a box, variable. Think of it as putting something into a container with a label. Examples: writing your name on a sticky note and sticking it to your lunchbox. Now everyone knows the box belongs to you. D. Logical operators. These combine multiple conditions, yes/no checks, to decide the final answer. Examples: I will play football if it is Saturday and it is not raining. E. Increment/decrement operators, simple counting. These are used to increase or decrease a number by 1. Examples: every time you like a post on social media, the like counter goes up by 1. 3. How operators work together. You can combine operators to build bigger logic. Example: teacher checks if your score is enough to pass the exam. Input and output operations. 1. What is input? Input means giving information to the computer so it can use it. Example: in programming, input is when the computer waits for the user to give data. 2. What is output? Output means the computer gives information back to you. Example: in programming, output is when the computer shows results, answers, or messages. 3. How input and output work together. Think of input and output as a conversation between you and the computer. 4. Why input and output are important. Without input, the computer won't know what you want. Without output, you won't know what the computer did. Hello, world. Program. 1. What is Hello, world? It is the very first program almost every beginner writes when learning programming. The program's only job is to show the message Hello, world on the screen. 2. Why Hello, world? The phrase is simple, short, and friendly. It immediately shows that the computer understood your instruction. 3. Breaking it down, even though the program looks small, it introduces several key ideas. A. Writing instructions, you are giving the computer a command: show these words, Hello, world. B. Running the program, after writing, you press a button or command to run it, the computer follows your instruction step by step. C. Output, the result is shown on the screen. In this case, the screen displays, Hello, world. This is called output, what the computer gives back after following your instruction. It immediately shows that the computer understood your instruction. 4. What you learned from Hello, world. How to create a program file, how to save it, how to run it, how to see the result on screen. It shows the entire cycle of programming without being complicated. 5. Step-by-step thinking example. Let's explain it in plain language steps. Start your computer and open your programming tool. Write an instruction. Display the message Hello, world. Save your program. Run the program. The computer shows, Hello, world. You smile because your first program worked. 3. Control structures cover subtopics. Conditional statements and loops. Control structures are the decision makers and organizers in programming. They control the flow of a program, whether it runs in order, makes a choice, or repeats something. Here are the key takeaways. Conditional statements allow a program to make decisions. They check a condition, something that can be true or false, and then decide what to do next. 1. If statement, used when we only want something to happen if a condition is true. 2. If-else statement, used when we want the program to do one thing if the condition is true, and another thing if it is false. 3. If-else statement, used when there are multiple conditions to check. The program checks each condition in order until one is true. For nested if statements, sometimes conditions are inside other conditions. In summary, if runs only if condition is true, if else either do this or do that, if else choose from many options, nested if one condition inside another. Loops lets a computer repeat a set of instructions until a condition is met. Instead of writing the same code many times, we can use a loop to save time and avoid mistakes. 1. For loop, used when we know in advance how many times we want to repeat. It moves step by step through a sequence, like numbers, letters, or items in a list. 2. While loop, used when we do not know exactly how many times we need to repeat. It keeps repeating as long as the condition is true. In summary, for loop best when you know the number of repetitions, while loop best when you don't know the exact number, but have a condition. Loops help computers save effort, just like humans avoid repeating boring work manually. For Introduction to Functions covers subtopics: what are functions, declare and call functions, and pass parameters and return values. A function is like a small machine inside a program. This helps programmers avoid repeating the same instructions again and again. Here are the key takeaways. What are functions? Set of instructions grouped together to do one specific job. Instead of writing the same instructions again and again, we put them inside a function, give that function a name, and then use it whenever we need it. 1. Avoid repetition. You don't rewrite the same code. 2. Make programs organized. Breaks a big problem into smaller steps. 3. Easier to update. Change the function once, and the change applies everywhere. For reusability, one function can be used many times with different inputs. Declare and call functions. 1. Declare a function. Declaring, or defining, a function means creating it and telling the computer what it should do. You give the function a name so you can call it later, a body, the actual steps inside the function. 2. Call a function. Calling a function means using it after you have declared it. When you call the function, you mention its name, you give it input, if needed. The computer runs the steps inside and gives you the output. Pass parameters and return values. 1. Pass parameters. A parameter is like a placeholder in a function. When you call the function, you fill in the placeholder with real data. 2. Return values. A function can give back a result using the return statement. This is useful when you want to use the result somewhere else in your program. In summary, parameters equal to what you give to the function, while return value equal to what the function gives back. Together, they make functions powerful and reusable. Thank you for watching our presentation. We hope it was valuable and informative. For questions, contact us at info@espincorp.com or visit our website. Thank you again and have a great day.